right, we'll see. Hi, kids in Project Adventure. All right, we are doing a do now. Going over the differentiation rules. You're going to be quizzed tomorrow on 18 of them. All right, let's go over the new ones. All right, what's the derivative of inverse cosine of u? Oh, okay. Woo! Good. Yep. All right, you got the inverse tan. What do you got? Beautiful. Your u squared plus 1. It's all good. What about derivative of inverse cotan u? Emily? All right. Derivative of inverse secant u. All right, Jess. Yep. Yep. All right, Riley. U squared minus. Good. Nice. So remember all the co-inverse trig functions, when we looked at the graphs, they were all decreasing. They all had negative derivatives. Right? And all the other inverse sine, inverse tan, inverse secant had graphs that were always increasing. Their derivatives were always positive. So is this too bad? Can we handle this? You can. But give yourself like a time limit today. See, I'm going to have these memorized by, this time. And then, like, give yourself a little check maybe 2 hours later. Make sure you still know. Yeah. Just straight writing. It is really just going to be exactly like this do now, the left side, and you're going to write down the right side. Just like that. Oh, we got a few more in here, don't we? I was thinking we were finished, but I wanted to just work on the new ones. So, I didn't include all the old ones in this do now. What about the derivative of ln of u, Amani? U prime over u. I already got you already. All right, Jess. Mm-hmm. Over what? Oh, Jess, you were so confident. You literally just gave me a heart attack. Okay, so the u is just like, so it looks just like the derivative of ln of u, but you have to put the ln of the old base. Now, what about the derivative of e to the u? Oh, you should show her, but just say yeah. All right, cheat. People at home can't see you. All right, Riley. E to the u times u prime. What if it's not e to the u, but some other number? We got to remember another piece in here. All right, Jeff. Yeah. Yep. Correct. Correct. And we said that, this works for both of these, because if it is e to the u, what's the ln of e? 1. So you have this one. The last one. Oh, I don't even know why this is in with the new ones. He just wanted to come along because he looked like him, What's the derivative of u to the n? All right, Manny. Times u prime times whatever the derivative of the inside is. Good? All right, so let's go over, I've given you homework on derivatives of inverse trig, on derivatives of exponentials, of logs, and we haven't gone over anything in a while. So I just wanted to spend a little bit of time going over some homework problems from either homework 37, 36, or 35. Anything you want me to go over? Problems? Can you go over everyone? Sure. Usually someone says that. This was saying that. Yeah, right. That would be so boring for you. But try to get a nice little assortment in here. Because, you have the answers. So pick things that are... I need a new page. Oh, yeah. That's really cute. Oh. Oh my goodness, I'm just messing this up here. This is a good one. All right, does anyone have a problem? I mean, with math? And even if you want to make up a problem, if there's something you want to go over, you just think it's hideous. Because, we had exponents to exponents, logs of logs, products. Yes, Amanda. Sure. Is there one on there you want to do? You want to do a new one together? All right, ready, guys? We're going to do a new one together. We're going to find the derivative of y equals, let's say it's 5 raised to the e to the sine x. Bam. Yes, equals. We want dy dx. Now, we need to know a few rules, right? We need to know that the derivative of a to the u is times u prime. And we have to know the e to the u rule, which is the same thing, but e to the u. Okay. So what's the rule I have to start out with? Is this whole thing an a to the u or the whole thing an e to the u? You gotta look at the whole thing. It's an a to the u. So we're gonna start out. With the a to the u rule, first factor of our derivative, you just copy. You copy. So the derivative, I'm gonna move this back, is 5 raised to e to the sine x. Was that hard, copying? No, that wasn't. The next step to take the derivative of a to the u. So we're starting out, and this is our u, and this is our a. The next step to take the derivative of a to the u is the ln of a. So what do I need next? The ln of 5. Very nice. The third factor of our a to the u derivative is u prime, the derivative of u. So I got to take the derivative of u, but u is an e to the u itself. So to get this u prime, I got to use my little e to the u rule. So good, so good. Okay, so we're taking the derivative of e to the sine x. What do I write first? E to the sine x, we copy, right? Times the derivative of the exponent, so cosine x. That's it. You can ask questions about any inverse trig, any exponentials. You can make them up. I just want to make sure I've answered, because I feel like we haven't been going over homework the last couple of days. It's been intense. Yeah. Okay. Like a log of a different base or an ln? All right. Now you want, so log, what's today's date? Today's log base 17. But what do we want in there, guys? You want an inverse trig? You want an exponential? An inverse trig? What's your favorite inverse trig? Okay. So a log base. Are we going to keep it of x, or would that be boring, Tim? Would that be boring? Tim says, chain rule it up. That's what he's always saying. X over 4. I'm sorry. He's determined. I have to go with that. I'm going to say so. All right. We want this derivative of that. I didn't make it up this time, so don't even blame me. These are your little friends. All right, now the other thing is I have to make sure. So we have to know how to find the derivative of the log base b of u. And do you remember now, Jeff? What goes on top? I would put the u prime over u first. You know what I'm saying? And then what's the only other thing you got to add? Ln of b down here. And you got it. Okay. So we do have to know that rule because that's what this is overall. It's a log base b of something, right? All right, gosh. All right, so initially when we're using that rule, this whole thing in here is the u. Right? Oh boy. Well, maybe we should start with the denominator. I think that would be easier. Okay, because the denominator, we just need to put down there the natural log of the base times u. So we have the ln of 17 times, yeah, the inverse cos, that whole thing here. The inverse cos of x over 4. And if you want to put an extra set of parentheses around it, some people like that, you can. You don't need them, but you can. Okay, so we got the ln of b times u down there, but we need u prime up there. So we need to know the rule to find the derivative of inverse cosine. Better write that down over here. The derivative of the inverse cosine of u equals negative u prime. Nice, guys. Okay, but now, here's the thing. U is no longer going to be this whole thing here. See ya. When I'm taking the derivative of the inverse cosine, our u is just that x over 4. Otherwise, x over 4 is the same as what? 1/4 x, right? That's the same as 1/4 x. Okay. All right, so we got to take that derivative and put it up there. That's going to be a fraction, isn't it? What do you want to do first? Or you want to do the negative u prime? Okay, so what's negative u prime going to be now? Negative 1/4. Okay, so we got that. Fractions over fractions. And then we need in the denominator the square. Where did we get the 1/4? Because x over 4 is the same as 1/4 x. So yeah, we're taking the derivative. Yeah, you don't want to waste a good quotient rule to take the derivative of that. Just write it. Okay, so now what do we need in the denominator of the numerator? Radical. X squared. Okay, we could either do x over 4 squared, if we put in parentheses, or x squared over 16 without the parentheses. No? All right, here's my last thing. I don't want to leave these complex fractions. I have a fraction over something else. Does this something else go up in the numerator or the denominator? Denominator. Now, that negative 1/4, I'd be tempted to write negative 1 over 4. I'm writing it. Oh, it should be. So negative 1, we could put the 4 down here. We've got the square root of 1 minus x over 4 squared. Then all this times the ln of 17 times. Well, this is lovely, guys. Good going. Way to scare the other kids at home who are trying to learn this. Now they just gave up because your examples. Yep. Yes, yes. Wait, the one that you guys haven't tried yet? That you just got, because I want you guys to work on that one. Let me see if I can come up with something similar.
That was just
Okay. You think we should divide? Okay. How about, what's bothering you about that one? What's bothering? Because I'm not want to do that one. That's 7 over x, that exponent? All right, what if I made it like negative 3 over x squared or something like that? Oh, well, this is, well, when you take the derivative of the exponent, when you get to that, this is an a to the u, okay? So it's going to be, you copy. Then I'm going to let you guys do this. Then what would the next part be? ln of pi. That's your ln of a, right? Derivative of the exponent. So what I would do for the derivative of the exponent, instead of wasting quotient rule, rewrite it as negative 3 times x to the negative 2. And then the derivative would be positive 6. Yes. So you could write it as 6 over x cubed or 6x to the negative 3 for that part. It has to be, why are you thinking of ln's for that? Oh, I see what you're saying now. The only time you have to use logarithmic differentiation if there's an x in both the base and the exponent. Okay? Yeah, if you have a constant either place, you've got a rule. Okay? You want to see a logarithmic differentiation? Well, the easiest one, you tell me, like, give me a function that has an x in the base and the exponent. That was the easiest one you could think of, really? Because once you have that 4 in front, now we're going to have the log of a product, and we're going to have to do the sum of the logs. No, I didn't want to order one. I want an easy one. You have to see when you have something like this, you can't use a to the u, because the base isn't a constant. You can't use u to the n, the power rule, because the exponent's not a constant. This is the only time you have to take the ln of both sides and then pick the derivative. Logarithm. So you take the ln of this side, get the ln of y. What happens when you take the ln of the other side? X times the ln of x, because it's the ln of x to the x, and you bring the exponent down. Then you take the derivative of both sides. What's the derivative of ln of y? Y prime over y. Or 1 over y dy dx, right? The other side, you have to remember to use product rule. So you have, what is derivative of ln of x? 1 over x plus the second times 1. And what does x times 1 over x equal? So y prime over y equals 1 plus the ln of x. And then to get, yeah, you multiply each side by y. So y prime equals y times 1 plus the ln of x. And if you want your derivative in terms of x only, yeah, you substitute in what it was equal to, x to the x. It seems scary. Oh, then it really is. Okay. Yeah, it's not so bad. All right, so now what you guys can do, oh, you have a question? Yeah. No, would I make you do, no, I won't do that. That was a good idea, though. I wish I thought of that. No. All right, so what you guys are going to do, you're going to work together on the review sheet. Officially, your only homework tonight is to study for the quiz tomorrow, like know those cold. But I want you to work on this review sheet together, work in groups a little, you know, if you can. If you don't feel like it, it's fine today. I'll get you another time. But try to get some done.